Okay, so for now, I will just move on to two-way ANOVA. So the two-way ANOVA sounds similar to one-way ANOVA. However, it focuses on finding out interaction between independent variables on the dependent variables. So what is independent variables and dependent variables? Usually when for a typical project, right, independent variables are normally your observations, your data, and dependent variables are the things that you try to predict to conclude. Okay, so similar to one-way ANOVA, two-way ANOVA is a hypothesis testing as well. The null hypothesis is that the independent variables are having interaction between each other, and alternative hypotheses are those independent variables are not having interaction between each other. So here's a link that where for you to know more about interaction. And another link here is references of the two-way ANOVA. Okay, so now I will just start my demonstration for the two-way ANOVA. Okay, so let's go back to our data files here, data analysis. Okay, for here you may notice there are two options. One is with replication, one is without replication. But however, for our case, right, because we want to find out the interaction between the independent variables. So let's do it with replication. Okay, so let's hit OK. Okay, similarly, let's select the data range. So in here, I include everything. I include everything in the data files. Okay, okay, the rows per sample, right? As what I mentioned previously, I have choose five different features, and each features I have 50 observations. So which means that rows per sample I have 50 each. And remember, it's very important that you have same number of rows in this particular inputs here. And otherwise, it will return you the error. Okay. So again, the alpha value, let's just remain default first. Okay. So let's hit OK. Okay. So now I will just teach you how to interpret this output. Again, let's just look at the ANOVA table here. Similar to one-way ANOVA, you can just either compare the f critical value or the p value with the alpha value just now, which is 0.05. So in this case again, right, cause f value is bigger than f critical value and the p value is smaller than the 0.05. So the data provide the sufficient evidence for us to reject the null hypothesis, which in that case that there's no interaction between all these independent variables that I have chosen. Okay, so yeah,